Welcome to this video where we'll outline the block-affine CRT proof of the Collatz conjecture. Let's start with block decomposition and single-halving steps. Start with an odd b. Compute t sub 1 equals 3b plus 1 divided by 2. If that is even, compute t sub 2 equals 3b plus 1 divided by 2 squared, and so on exactly n times until 3b plus 1 has been halved out its full 2 power. Then factor out every 3 power in the resulting even number 1 halving at a time, are steps. Altogether, you perform n plus our successive single halving divisions by 2 before you arrive at the next odd value b prime. Now, let's examine the one block affine law. Because the whole block consists of those single halving steps, one can collapse them into a single affine formula. b prime equals 3 to the n divided by 2 to the n plus m times b plus 2 to the m minus 1 divided by 2 to the m, where m equals v sub 2 of h times 3 to the n plus r minus 1 is the number of further halvings to make the top odd. Let's move on to the loop assumption and difference layer identity. Assume a non-trivial period of blocks exists. Define delta sub I equals b sub I plus 1 minus b sub I. A telescoping sum over the blocks produces the exact linear identity sum from I equals 1 to of kappa sub I times delta sub I equals 0, with explicit positive integer weights kappa sub I equals 2 to the prefix sub I plus n sub I plus m sub I plus 1 times 3 to the suffix sub I. Next, we'll discuss the slot constraint mod q. Reducing mod q gives a single coordinate linear constraint inner product of kappa and d congruent to 0. We call this hyperplane, the slot, h sub q equals kernel of kappa transpose. Let's continue with slot saturation by backward branching. By stepping blocks backward, choosing the odd cofactor h sub I at 2 adjacent edges, we show the map is surjective onto every slot point mod q. In particular, any d in h sub q can be reached by a finite backward branching path. Now, we'll examine the CRT contradiction in a 2-coordinate window. Next, pick 2 primes. An offset prime q dividing 2 to the m plus n minus 3 to the n, so period closure implies a non-trivial local congruence mod q, and a slot prime q prime not equal to 3, so backward branching fills h sub q prime. At the same pair of adjacent indices, I and I plus 1, this yields 2 independent affine lines, one coming from the slot constraint mod q prime, one from the offset transport mod q. By the Chinese remainder theorem, they intersect only at delta sub I plus 1 equals 0. Since the slot is fully saturated mod q prime, no non-zero common solution exists. Therefore, the only possible d vector around the loop is 0, which violates the block loop identity unless 2 to the m plus n minus 3 to the n equals 1. Finally, we'll look at the conclusion by mint or contract Lyapunov. An explicit mint or contract Lyapunov argument shows that any bounded orbit must collapse to 1. Since no non-trivial cycle can exist, every positive integer reaches 1. This completes our outline of the block-affine CRT proof of the Collatz conjecture. We've seen how the single-halving block law, the sum kappa sub I times delta sub I slot, the CRT two-line contradiction, and the concluding Lyapunov bound come together to prove this famous conjecture.